The next application we're going to look at is finding arc length. And here in this diagram, we'd be finding the length around the curve from θ1 to θ2 as shown. We consider a small element of that arc length here. P, as before, would be r, theta, and Q, as before, would be r plus delta r, theta plus delta theta. In the magnified diagram here, the element has an arc length of delta s, and that's what we're trying to find. Since the length of this side of the element is r plus delta r, and of this side is r, we can see that this length here would be delta r. The red section, although drawn as a straight line in both diagrams, is actually the circular arc going from a radius of r. So if P is here, that element is the circular arc here. Since the angle in the middle here is delta theta, and we're working in radians, the length of that circular arc will be r delta theta, as shown in the diagram here. Then when we take delta theta as being small, we can approximate that by a straight line. We can also approximate this arc by a straight line, and then we have a right-angled triangle, which is right-angled here, so our delta s is the hypotenuse. That means we can say that delta s squared would be equal to delta r squared plus r delta theta squared. At least that's approximately equal to. Now, that means that delta s squared over delta theta squared would be approximately equal to r squared delta theta squared over delta theta squared plus delta r squared over delta theta squared. And those will cancel there. And so that's delta s over delta theta squared is approximately r squared plus delta r over delta theta squared. And then we just take the limiting argument as delta theta tends to 0, and that becomes ds d theta squared is approximately r squared plus dr d theta squared. And therefore, ds d theta is approximately the square root of r squared plus dr d theta squared. Which leads us to the arc length formula that s is equal to the integral from theta equals θ1 to theta equals θ2 of the square root of r squared plus dr d theta squared, d theta